Yeah. Now this would be our first example for eccentric loaded riveted joint. Okay, so we have this is a question. This is a bracket given with 1, 2, 3, 4, 5, 6, 7 rivets with the P and the eccentricity and the distance from center to center as C. Okay, so read the question. An eccentrically loaded lead riveted joint is to be designed for a steel bracket as shown. Okay, the bracket plate thickness is 25 mm. All rivets to be of the same size. Okay, so that means same diameter, which is unknown. Load on the bracket P, that means this is 50 kilonewton. Rivet spacing, that means all the C here is 100 mm. Okay, and the load arm, okay, that means the eccentricity is 400 mm. So your CG is roughly around here. Your CG is roughly around here, this vertical line here. So when you fold up, okay, this riveted system here, okay, it would be the center here about this axis, but the X you don't know where. Okay, so the Y coordinate is unknown, the X coordinate can be found by taking this distance here. So the permissible shear stress is 65 megapascal and the crushing stress is 120 megapascal. Find the size of the rivets to be used for the joint. Find the size of the rivets to be used for this joint. So that means you have to find the diameter. Okay, so these are the given data from the question. Okay, and this is the system, the riveted system. So what you need to do is, first thing is you draw x-axis through rivet 5 and 6, the center of rivet 5, 6, and then another line that is your y-axis through your rivet 1, 7, and 6. And of course, you have to label the rivets. Let's say go in clockwise order. So 1, 2, 3, 4, 5, 6, and 7. Or you can name this 1, 2, 3, 4, 5, 6, and 7, up to you. Okay, so you need to draw this diagram. The first thing is you need to draw this diagram, putting the Y reference axis and the X reference axis and the Y reference axis. And then on each rivet which you have labeled, okay, draw vertical arrows like this, okay, which represents or which is the same as what you have for this arrow here. Okay, so this is acting vertically downwards. So all these forces here, primary shear force, will be acting vertically downwards like this, PS. You can see all the PS. So you can name them as PS because they will be the same, all the same. So P1, P2, P3, P4, P5, P6, and P7. Okay, then, okay, you need to find the CG. After that, you need to find the CG. So to find the CG, you have to use this. Now the A has been missing. Why the A has been missing? Because they are common, so you can cancel off the A. So what you have, the coordinates of X bar and Y bar is X1, X2, plus X3, plus X4, plus X5, add up to X7. So of course, you need to know what is X1. So how to measure X1? So from the center of rivet 1 to Y-axis, this should be 0. Then from the center of rivet 2 to the Y-axis should be 100. Then from the center of rivet 3 to the Y-axis, this should be 200. Then from the center of rivet 4 to the Y-axis, this should be 200. From the center of rivet 5 to the Y-axis, this should be 200. And then 0, 0, 0 for 1, 7, and 6. So putting in all the values here, so you will be able to find X bar is actually 100 mm. Okay. Then find out your y1 to y7. So from the reference axis, x-axis, okay, y1 should be 200. Okay, y2 also should be 200. y3 should be 200. y4 should be 100. y5 should be 0. y6 should be 0. And y7 should be 100. So putting in all the values here, divide by number of rivets, that is 7. So you get 114.3. That is your y bar. So that means this is 100 here. If you draw a line across, that should be 100. So 114.3 should be slightly above this center line here. The 114.3 should be slightly higher. So let's say here. Okay. So now once you have found out the G point, the center of gravity, then draw your radial lines of L1, L2, L2 is missing here, L3, L4, L5, L6, and L7. Okay. So, and then all the primary shear loads you can calculate based on the 50 kilonewton divided by 7 rivets. So you have 7143 Newton. Okay, so all the direct shear load, that means the primary shear load P1 to P7 should be 7143. Then you find the turning moment. Of course, this diagram must be completed by now. Okay, this diagram should be completed by now. So you can see your theta 1. You have to mark down your theta 1, okay, based on the parallelogram that you have drawn. So you should know roughly where are the angles. Then this is the angle. Then this should be the angle. Then this should be the angle here. And for this angle here, sorry, I didn't mark it in black. And for this angle here, theta 6. And for this angle here, theta 7. So once you draw your parallelogram, you know, okay, what angle you should draw. Okay, what angle you should consider. So P times E, that means the force here just now, P, that is 50 kilonewton, times the eccentricity, that should be how much? 400 mm. Okay, so you got your turning moment P, that is your turning moment. That is P times E, based on P times E, okay? So now you have your F1, F2, F3, F4, F5, F6, and F7 labeled. Okay, those are the secondary shear load based on rivet from 1 to 7. And then the radial lengths you should label L1 to L7. Okay, then you need to find out L1, L2, L3, L4 up to L7 based on Pythagoras theorem or your simple trigonometric functions. So you have what if, let's say for example, you want to measure L1. You must know what is the length here. And this length here is 100. This length here is how much? This length here should be 100 minus 4.3, 14.3 or 4.3. Let me see. 100 minus 14.3. So that means it is 100 minus 114.3. So that means this length here is how much? Okay. So this length here is how much? So that means here you are taking reference here. So this is 114.3. So that is total 200 here. This is 200, total 200. So 200 minus 114.3, you will get this vertical length here. Because from here to here is 200. And then from here to here, because you are taking reference to your y-axis, sorry, from here to here is 114.3. So this length would be 200 minus 114.3. Okay, and then this length here should be 100. Okay, so you see this. So applying Pythagoras theorem, L1 and L3, L4, L7, L5, L6 also applying Pythagoras theorem. But the lengths are, of course, are different. So length L2 is direct, so you just take the length L2 directly from the diagram. So that is from here to here. Okay, from here to here. So that should be 200 minus 114.3. So you will find out all the lengths from L1 to L7. And then remember this formula, okay? This formula here, which is also equals to PE. So you have to find out F1, all the lengths you have already calculated. So from here, you can change F1 to be your subject. Then you can find out F1 to be 24,244 Newton. Okay, so based on the formula that we have derived just now, okay, place your F1, which you have already calculated with all the lengths. You can find out your F2 to F7 is how much. So once you got your P1 to P7, F1 to F7, calculate all the angles of cos angles of cos theta, cos theta 3, cos theta 4, and cos theta 5. Of course, you need to calculate theta 3, 4, and 5. Okay, but then all these angles can be used and be based on simple trigonometrics. Now, why only 3, 4, and 5? Now, based on the diagrams that you have, 3, 4, and 5, these three rivets is the closest to the P load applied here. It's closest to the P load that is applied here. So these three rivets will be the rivets that is subjected to the highest resultant force. Okay, so you don't have to actually calculate R1 to R7 everything. If you want to calculate everything, you can do so. But then actually you don't have to calculate R1 to R7 throughout. You need only these three rivets. If, let's say, for example, it refers to this system of rivets. So why only these three rivets? Because these three rivets are the closest to the P. So these three rivets will tend to fail first before 2, 1, 7, and 6. So that is why we take 3, 4, and 5. Okay, so 3, 4, and 5. Calculate out the angles. Use the resultant formula. Resultant primary shear load P1, P3 you can consider square F3 square plus 2 times P3 times F3 times cos theta 3 square root, then you get the resultant 3. Resultant 4, resultant 5. So among 3, 4, and 5, you have to pick which one is the greatest. This one, 33, 121. So 33, 121 will be the maximum resultant load. So place it into this formula, find out the diameter of the rivet. Find out the diameter of the rivet. And then remember crushing stress, crushing area is D times T, yeah? D times D for each rivet. So consider the maximum load that is 33121 based on the crushing stress, crushing area, that is this, calculate out the crushing stress. So your calculated crushing stress is 51.95 megapascal. But then the given crushing stress is 120. So that means this value here is less than 120. So that means it is safe. Safe. Okay? So that's all for this example. That's all for this example.